Yeah, all right, thank you very much. Hi, I'm Andy. If you see me on Discord or Twitter, I'm Kooshaba, and I've been working at Lattice since the beginning. I'm mainly a game developer, actually, and I started in just general game development, and that's how I kind of, oh, classic. All right, let me turn on the don't sleep mode. Okay. So yeah, I started in crypto as a game developer, and my first crypto project was Dark Forest, actually. So that's where I came from before this. Dark Forest is an on-chain RTS, if people haven't heard of it. But I'm mainly interested in crypto with like what it can do to give players more features. And that's the avenue that I like to take with all of our mud development. So at Lattice, I'm mainly working on our internal game studio, making another on-chain RTS game called Sky Strife. So first, I'm going to go through a little mud 101 and just quickly, show of hands, who has written a mud contract here before? OK, that is very good that most of you haven't, because now this mud 101 will make sense and I won't bore you. OK, great. So I'm going to go through a little bit about mud 101, which is like why mud, why did we do this, the basics of how to make a simple contract. And then I'm going to go a little bit into the, oh, what's up? The primitives that we have, which are store and world, and like what these things mean. You're going to hear these words thrown around a lot if you're in the Lattice Discord. And then I'm going to briefly go into Sky Strife, talk a little bit about how mud empowered us to build Sky Strife, and then we'll do a short live demo of playing Sky Strife. All right, so let's jump into it. Mud 101. I'm going to bore you with some like simple Solidity shit beforehand so that we can compare it to mud. So this is not a Solidity tutorial. I'm just pointing out how things work. So old world, contracts can store arbitrary data types. This is the power of Solidity, right? It's a programming language and a database built into one. The EVM is very powerful, very cool. But what happens if you actually want to interact with this data? Technically, you can store them in arbitrary positions, but if you want to read those arbitrary positions, you need to know where to look. And this means like running a full node, getting access to that memory, and then shipping it off to somewhere. This is traditionally done with getter functions. You store something in storage, you make a getter function that powers it, you call that getter function somewhere on your client, the RPC powers it, you hydrate your client. Sounds simple enough, everyone does it, whatever. This gets hairy, right? When you have large amounts of data and you want to serve this data quickly and inexpensively, honestly. Like, I don't know if any of you have written an inefficient RPC call on your client before and gotten hit with a giant bill. It is not super fun. So we have things like the graph, where you're writing assembly script or whatever to power your custom application. And you have to re-describe your entire contract in this custom language to get things into your client. Which, working on Dark Forest, this was like, I don't know, 40% of what I was doing was just like getting things into the client, all the custom data that we were using for the new features we were shipping in our game. So we thought we could do better. So we came up with this mud store. So the promise of mud store is you have no getter functions, or no custom getter functions, no events, no indexers, no networking code. All of this is taken care of for you. And the way we handle that is everything is defaulted. If you've ever used a web framework like Next.js or Rails, Mud is kind of taking that approach where we're putting you in a box, we're putting some restrictions on what you can do, but if you accept those restrictions, you get all of this for free. And I will show you how that's possible. So we have a standard data model for all mud storage. You can't just arbitrarily define storage inside of your contracts. Everything needs to be defined in one mud config file. Now the beauty of that is that, one, all of your storage is in one place. It's easily searchable by a new developer, let's say. But two, we can actually generate Solidity code based on that configuration file, so you never need to write event emitters, getter functions, or storage ever again. So this is where the optimized core library comes in. So we have the standard data model that gets transformed into using our core library. And then we have our own custom storage layout to back that. Now we do some fanciness on the storage layout. We pack things a little more efficiently than Solidity in certain situations. But basically, you don't need to worry about that, because most of the time you are just dealing with the generated table data. So a table is what we call the thing that stores all data in mud. This is what, you could think of it, don't go crazy with this analogy, but you can think of it as a SQL table, right? where there's keys that reference rows in the table. And this could have arbitrary schemas associated with it, right? This is a position, it has an x and y of int32. You can even get more complicated with compound keys. Something like a balance is really well suited for a compound key, owner and item tupled together, and then you can store the amount associated with that. So here's an example of like what our optimized core library is. This is the interface that a developer will be using. So all you need to do is you need to set the record with a specific table, key, data, and everything else is taken care of for you. And this is even enhanced because we don't even need to reference the core library directly at all. We will generate table-specific libraries for you, and you just simply import them into your contract, call set, it gets stored, the events get emitted, the indexer picks it up automatically. So this is just another example of a position table. Oh, and we do a lot of kind of syntactic sugar around the schema as well. So if you have a bunch of different data types, we have helpers for setting each individual field in the schema. So the power of this is this default indexer, honestly. So for example, when I'm working on Sky Strife, I write a new feature, I add 10 new tables. We have a default indexer that is just pointing at our testnet, and it is picked up automatically. Like the indexer is constantly watching for deploys, it detects a new mud world, it starts consuming all these events, and I hook my client up to it, and it suddenly is just hydrating from this indexer instantly. And this is not some proprietary thing. The indexer is open source. We can point it at any network right now, and any one of you who deploys a mud world to that testnet or mainnet will get picked up by these indexers. And you could run the indexer yourself if you really don't want to deal with someone else's infrastructure, or if you don't want to index all the worlds, right? That's a lot of data. You could run an indexer specifically for your application, point it just at your smart contract, and it will just grab your events. The point being, there's no custom code in this indexer per world. Like, it just happens. Event, yes. This is a little technical. OK, we do actually have a SQL database backing the tables on the indexer, though. That is kind of a cool thing. So we don't have like full open access to this yet, but there are plans to have an endpoint where you can just arbitrarily have read queries at this database. And you can imagine how powerful that is for like if you have a data team that just needs to know what is going on in our application. This is instantly available. Basically, your own custom Dune analytics for your individual contract. So this is why you should use Mud Store. This is the foundation of Mud. And it really is not that bad in terms of restrictions. It's just a little bit of a mental flip on where you're putting your literal storage rights. Now, if this alone was available, I think it would be pretty exciting. But we've packaged all of this up into an abstraction on top of it called the Mud world. Now, we get a little more fanciful here. This is a little more future thinking. But this is what I'm most excited about as a game developer. So let's say you deploy an empty mud world. There's nothing in it to start. And there's no tables, and there's no systems. Systems are the pieces of logic that operate on tables. I come in, I'm the owner of this world, I'm the root developer. I can deploy in namespace A. Let's say that's the root namespace. And I deploy all my 10 tables, a couple systems to interact with those tables. All well and good. I write a client that reads from the root namespace, and everything is hydrated automatically for me. Sure. Someone else comes in and actually can deploy a namespace, tables, and systems onto that same world. Now, the client by default does not read from this additional namespace. That's kind of, it's an attack vector. You can kind of DDoS people's clients with this information. But the mud world doesn't get hurt by this additional namespace. And by default, all these additional namespaces that people can register have read access to all the tables in every namespace. So let's say, for example, in Sky Strife, it's a RTS game. Someone deploys a DAO on top of Sky Strife that helps people play the game. Like, it actually controls their units for them. It could read the unit data from the base game, but you can't actually write back to it the core root namespace unless you are given permission to do that, like explicit approval. So it's this kind of by default, you're given read access to everything, but as systems become trusted, as namespaces become trusted, you can opt in to giving them access to deeper and deeper parts of your application. And of course, this could be done in a number of ways, right? Like there could be a DAO that deals out explicit permissions for certain subsystems of your application. Maybe there's a very holy namespace at the baseline of your application that can never be touched. But there's a bunch of tangential things that could be more easily given access to without breaking everything. So I'd like to go into like a little theoretical case study of what it would look like to just deploy a simple ERC 721 contract inside of a mud world. Now, right now this is possible. You could take a standard ERC 721 contract, put it in a mud world, and just change the way it writes to storage, and it will just work. Like you can emit non-mud events from a mud world, no one's going to stop you. But you will also get all the power of mud to be able to build a custom client on top of your ERC 721 contract. Let's say a custom dashboard with custom functionality that is not, you don't get that for free inside of the standard contract. Now let's say someone comes in and actually deploys a game inside of my mud world that uses those tokens. That is entirely possible. No one can stop them from deploying this game. And they could write their own custom client that reads just from their namespace and then pipes reading information back to the root namespace. The power of this is that this is completely permissionless. They didn't need to ask for approval from you to use their assets. And they can know for certain, because it is on-chain, that every player in this game is not lying about their assets, not lying about their access to the NFTs. And what if people start building on top of this third-party namespace? It's very possible that this third-party developer hit a niche that you weren't thinking of. And there's a bunch of different applications that pop up as a consequence of that. So we have casinos, other games, marketplaces, whatever. And then at some point you talk to the developers and you're like, okay, we trust you. We're actually going to give you permissioned write access to some of our internal tables. So maybe what this would look like is that game actually now has permission to transfer and burn NFTs from people based on in-game actions. You duel to the death with someone else, and the NFT actually gets transferred to the winner at the end of it. It's like racing for pink slips. So this is all possible within the current MUD structure. We are just trying to open this idea up to people because this has not been done before. And I think it's a different way of structuring your thinking about deploying a contract. And then a quick overview of what this would look like from the client perspective. Your default client would just read from the root namespace, but as you see new namespaces come in, you could say, oh, this namespace is actually incredibly interesting. I'm going to start, by default, loading that into my client, and then my users can start playing with all this additional information that's been built on top of it. And I can show in Sky Strife how that's a very easy thing to do, and it's like very easy to expose to your users and developers. So, okay, going to briefly talk about Sky Strife. This is 100% of what my brain does all day. I'm just making this fucking game for so long. Oh my God, it's not that long. It's been a year, but it's like constant development on Sky Strife. It's very exciting though, especially because I come from Dark Forest. And if you don't know Dark Forest, it's an on-chain RTS game. But what you probably don't know about it is that working on that code base was a nightmare. It was really, really difficult. It tested every fiber of my developer being, just like getting simple features into it. But it was worth it. It was like a cool cultural experiment. But after that, I was pretty exhausted, and I was like, it was unclear if I was going to work on-chain games again, because I was like, if that's what it takes, if that level of effort to make a game on-chain, it's not worth it. It's not worth my sanity. But then MUD came along. So I was very ready to accept any game engine, but MUD has made my development experience with Sky Strife honestly pleasant. I'm excited to ship new features. I have no fear of going forward. So yeah, I don't know this slide deck well enough. Okay, that's the history. I guess so Dark Forest really was the impetus for both MUD and Sky Strife. So the history is Justin, the CEO of Lattice, worked on Sky Strife for a bit, was like, oh shit, this is crazy, and then forked it and tried to make another game. I came in after him, worked on Sky Strife, was like, oh shit, this is crazy, but it kept going. I just kept working on Dark Forest. But inadvertently started in parallel working on these things. Like I started working on my own on-chain game engine at the same week that he called me saying, oh, we're making an on-chain game engine. I was like, oh shit, okay, this was meant to be. So now Mud and Sky Strife are developed in parallel. And not only in parallel, we give and take from each other. Sky Strife is the ultimate dog fooding of Mud. And really what's happening is Sky Strife is protecting most people from breaking changes in Mud. So like Mud is finally frozen, like there's no more breaking changes, but the last 6 weeks have been a wild ride, a lot of rewrites. But no one has seen them except for us, so that's good. The Mud developers get to sleep easy. So the goals of Sky Strife were, one, maximize developer productivity because I didn't want to go insane again. Minimize custom infrastructure. I don't want to write assembly script. I don't want to deploy to the graph. I don't want to have to worry about that. And most importantly, no compromises on gameplay. It needs to be fun. Because the constant conversation we would have in Dark Forest is like, oh, wouldn't it be cool if, and the conversation would end there because we'd start talking about infrastructure problems and it would never actually happen. Or if we did get to do it, it would take 8 weeks to get the feature in anyway, and all steam had been lost. So I can show a little bit about how far Sky Strife has come. It is, this is one Mud world that you are playing an RTS game similar to StarCraft or Age of Empires, and I think it's pretty fun. And my little pet experiment that I like to do with people is I just like to show them the game, and if they know nothing about crypto, I won't mention Web3, I won't mention a blockchain, and they'll play the game and be like, wow, this game's really slow. I'm like, all right, I'll take that. But you didn't realize there was any transactions happening. That's good. So yeah, here's just a little bit of stats on the Sky Strife code base. It's 60 plus tables, 20 systems. We are constantly shipping and we're running weekly play tests. And there's like a big ongoing play test going on right now in one persistent world. And it is a massive Solidity code base. There's a lot in it, but the effect of the Mud tables and the Mud systems is that each feature is very well compartmentalized. Like I can safely gut the combat system, completely change everything, change the way it handles storage, and no other aspect of the game cares about it. And that's all I want. Like if there's going to be complexity, at least keep it in its own little silo so it doesn't infect everything else. And okay, I'm going to sit down and show a little bit of gameplay. So when you come into the Sky Strife main menu, we really just wanted it to feel more like a standard game main menu and not a Web3 client. So there is this wallet connection thing, but it is not required at all. Like someone can come in and just spectate matches forever and not play, and you never need to know that it's a crypto game. But I'm gonna join here. My wallet connection is not enabled. I'm like a local burner wallet. But in the live game, another thing we wanted obviously was you don't want to have a MetaMask pop up every single time you go to move a unit in Age of Empires. So we have built-in account delegation inside of Mud, which I know everyone says account delegation is this like crazy difficult problem and it's like the next huge unlock for Ethereum. But if you keep everything in one Mud world, account abstraction is really not that difficult because we have control of the entire pipeline. And account abstraction basically becomes, oh, there's a mapping of my main wallet to this burner wallet, and if you see this burner wallet make an action, just loop it back to my main wallet, and that's it. And you can invalidate that account delegation at any time. Oh. Okay, so when you spawn in, you have a hero unit, and you just are going to move around and build units and fight things. Who here has played an RTS in their life? Okay, all right, yeah, everyone knows what's going on here. Yeah, you're moving units around. It's like Fire Emblem, Advance Wars, whatever. It's just a slower version of it. So we're running on a testnet right now with a block time of 1 second, 100 million gas per block, which is, it's stretching it a little bit, but we're deploying to mainnet, and it looks like we're going to be able to hit those capabilities on mainnet as well, on mainnet rollup. And unfortunately, I'm not playing with anyone right now. I have my stupid bots in the game who have decided to quit. They're not doing anything. So you're just going to watch me smack some towers. But yeah, I'll wrap up. Sorry. Yeah. This is my baby, all right? I've been working on this for a year. the point being, this is all fully on chain. This is a proprietary client, I guess. Like, we make it in-house, but there's nothing stopping people from making completely custom clients. And here's an example of a custom leaderboard someone made to track all of the winnings that people have gotten from matches. And this is just, all they needed was our mud config file, and that's it. They can derive and the ABI. They needed the world ABI and the mud config file. They linked up to the default indexer, and they have all the information that we have access to without writing any networking code. So we're very excited for someone to come and make an Unreal 5 port. Very possible, and they could start charging money for it. I can't stop you. And yeah, that's it. Thank you.